Hello, my name is James Holland, and I'm a PhD student working with Rank's research group. Today, I would like to share with you the progress of our project, the contributions this makes to the goals of the STRIDE group, and lastly, how to use our tools to improve the resolution and accuracy of the PTV Vissim traffic simulation software. Cooperative automated driving systems can be simulated using a vehicle dynamics simulation tool, such as CarMaker or CarSim, or using a traffic microsimulation tool, like Vissim and Aimsun. Vehicle dynamics simulation tools are mainly used for verification and validation purposes on a small scale. Traffic microsimulation tools, however, are mainly used for large-scale verification purposes. Vehicle dynamics simulation tools can simulate longitudinal, lateral, and vehicle dynamics for only a few vehicles in each scenario. For example, CarMaker and CarSim allow for simulating up to 10 and 20 vehicles respectively. Conventional traffic microsimulation tools can simulate vehicle following, lane changing, and gap acceptance behaviors for many vehicles in each scenario without simulating individual vehicle powertrains. Vehicle dynamic simulation tools are more resource intensive but result in higher accuracy than traffic microsimulation tools. Due to the limitation of the software architecture or computing resources, simplifying the underlying assumptions used by conventional traffic microsimulation tools may have been a necessary compromise long ago. However, to enable the adoption of cutting-edge connected vehicle technology, there is a need for a simulation tool capable of optimizing computational complexity and accuracy to simulate many vehicles in each scenario with reasonable accuracy. The developed simulator can calculate and export the necessary information to improve the accuracy of traffic microsimulation tools, such as Vissim, in order to customize and control the scenario in the same manner as the native GUI. Next, I would like to briefly discuss how the application works and how to get started using it. Firstly, the application is written in Python and can be executed by running python-m main.py from the command window within the GUI folder. With the main window opened, you are greeted with the About page that provides details about our lab, the application, and system requirements. Following the About tab, there are several tabs that allow for adding and defining leader and follower vehicles, environmental variables, and constants. To manipulate leader vehicles, navigate to the Leader tab. Here, it is possible to add, remove, and edit the leader vehicles. The leader vehicle is composed of a unique ID for indexing the vehicle, as well as body and brake IDs that correspond to the specific vehicles seeking to be modeled. Lastly, the drivetrain type and drag coefficient can also be defined. Follower vehicles, on the other hand, take only a leader vehicle's ID, driver type, and unique self-identifier as arguments. Similarly, the operating environment is composed of IDs that describe the atmospheric and pavement conditions, as well as the grade of the roadway. Platoons use a defined speed profile as reference for the control function, which is defined via the unique identifier. The Longitudinal Control Variables tab displays the desired speed of both the leader and follower vehicles at each time step of the scenario. By selecting the Plot button, the speed profiles for both vehicles are plotted against each other. The Export button allows for printing the speed profiles to a CSV file for importing into Vissim. The main.py script is responsible for managing the main GUI, with each of these setup scripts handling individual configuration option windows. Ranks Research Group would like to thank our undergraduate researcher, Miguel Fuentes, and graduate students Noah Simpson and James Holland for their work and contributions to this project. This work was sponsored by a contract from the Southeastern Transportation, Research, Innovation, Development, and Education Center, a regional university transportation center sponsored by a grant from the U.S. Department of Transportation's University Transportation Centers program. The contents of this report reflect the views of the authors who are responsible for the facts and the accuracy of the information presented herein. This documentation is disseminated in the interest of information exchange. The report is funded partially or entirely by a grant of the U.S. Department of Transportation's University Transportation Centers program. However, the U.S. government assumes no liability for the contents or use thereof. I hope they enjoyed this demonstration and find these tools to be beneficial in your work. Thank you for your time.